So this is going to be chapter 19, just a quick review on transformers. We're going to talk about step up as well as step down transformers, just really quick, about maybe 10 minutes worth of review on this. So first of all, if I have on the left side here is our primary, it's 120 volts, 60 hertz, and we're going to use this as an RMS. And we'll talk about how I got the 20 volts RMS on this side in a second. So if we have this ratio right here, 6 to 1. The 6 to 1 actually means there's 6 turns in the primary to 1 turn in the secondary. So when you know this is going to be a step-down transformer. On our secondary side, I'm going to put a RL 100 ohms. So if I have if I'm looking for the voltage on the secondary right here, what I could do is put in the 6 to 1 here and 120 over the VX. And that's just using this equation. Using simple cross multiplication, I could take 120 volts RMS and divide it by 6, which gives me 20 volts RMS. So you say that is 20 volts RMS on that side. Now, since I have a load resistor, and this is a AC circuit because we have a current that's oscillating back and forth there, we can say that the current in the secondary is just the voltage in the secondary, RMS, divided by 100. Since there is no inductors or anything to the circuit, I can basically use this simple Ohm's law equation. 20 volts RMS on 100 gives me 200 milliamperes of current. So that's how we do a step down transformer. We can see that this is definitely a step down because we've gone from 120 to 20. This is the most common type you'll see on an industry. We do have step up transformers. Step up transformers are not as used as often, but they still can be used. Alright, so what I'm going to be doing here is we're going to look at a step-up transformer here. So we got a 1 to 6 ratio, so I just flip these two. What we're actually going to do is figure out the current in the secondary as well as the power in the secondary, square RL. I forgot that. So we have those two right there. First thing is, to get this to prove that this is a step-up transformer, just use the turns ratio. That's 1 primary to 6 secondary. So I just take 6 times 120 volts, gives me 720 volts RMS. To get the current in the secondary, I take the voltage in secondary and divide it into the low resistance, and that gives me 7.2 amperes of current. Now, just to let you know that you could do is do IS over IP is equal to VP over VS. Just make sure my equations are correct, and it should come up with the same answer on this. So. But you could use that. But I just use simple Ohm's law on it because I only have a single resistor, which makes pretty much sense. Why make things hard? This equation is a little more difficult. Use simple equations. So what about the power? So let's find the power in the secondary on here. The power in the secondary, what we could do is I squared RL, or I could do is pi. So P secondary is equal to I times E. So we can do it two different ways here. So I'm just going to do I squared RL. So if I do I squared 7.2 amperes squared times by 100 ohms, well, I'm just going to keep that at 7. I'm just going to do math in my head here. 7 squared is 4,900 watts of power here. 4,900 watts, 4.9 kW of power. That is quite a bit of power on this circuit right here. So yeah, we would not be able to. We would definitely not be able to use this 100 ohm resistor on this circuit. So if you have any questions on this, please feel free to contact me. Thank you. So basically, 4,900 to 5,184 watts. And that's watts of power on this. On the side. So that is step up, step down transformers. If you have any questions on that, please feel free to send me your thoughts, provide me some feedback, and I'll get back to you on it. Thank you.